Okay, ladies and gentlemen, I'm going to go over some chain rule here from the chain rule worksheet. And let me find this worksheet here for us. And this is what we're looking for. It's called derivative and chain rule. So I'm going to put this in the comment section for you all, since this is what I want to go over. So we're going to go over some of these examples. We're going to do some of the odds so that you guys can verify that you're doing them correct. Okay, so number one, y equals x minus 8 to the 12th power. So here's the worksheet. This is the stuff that we were working with today. Okay, so remember how we started this process. We have our u here. So we let u be the inside function, inside the parentheses, x minus 8. Then that means y is u to the 12th power. So let's move this down here. Now the chain rule portion is to find the derivative, dy dx, which is dy du times du dx. So dy du is found with the blue. Du dx is found with the red. Okay, so we're going to try this out here. So let's move this. All right. dy du d du u to the 12th power, which gives you 12u to the 11th power. So this is what we did earlier using chain rule. Here's our chain rule formula. But we need du dx. So du dx is the derivative with respect to x minus 8. And this derivative is 1. So this would be times 1 now. So altogether, go back and we say dy dx is 12u to the 11th times that 1, but remember what u is. U is x minus 8. So we're going to replace this u here with x minus 8. That's where u is. So our final answer, dy dx, is 12 x minus 8 to the 11th power. Now times 1 is itself. So this is how we started to get a handle on using that chain rule formula. 1 times itself is itself. 1 times anything is itself. I apologize. And so here's your dy dx, ladies and gentlemen. So we want to go through the chain rule that we did earlier today. And we're going to get you guys some videos here for some of these questions. Hopefully we'll do as much as we can. Number 3, y equals the square root of 3x minus 5. Okay. Now we can write y here being 3x minus 5 to the 1/2 power, where the u function is inside the parentheses. This is the inside function again. So we let u be 3x minus 5. Then that means y becomes u to the 1/2. Okay. Chain rule. dy dx is dy du times du dx. I'm going to focus on these colors. dy du is d du of u to the 1/2 power and this is 1/2 u to the minus 1/2, which is 1 over 2 square root of u. So I have 1 over 2 square root of u for dy du. du dx. d dx, 3x minus 5, and this derivative is 3. So I replace this with 3. So don't forget what u is again. U is 3x minus 5. That goes down here. Okay, 3x minus 5 down there. So we're going to replace that u with 3x minus 5. And finally, you have, by chain rule, dy dx, 1 over 2 square root 3x minus 5 times 3. And you can see this very often as multiply the 3 with the 1. You're multiplying a fraction times a whole number, essentially. A rational times a whole number. And there you go. And that's number 3. Okay. Number 5. Y equals 3x minus 8 to the 7th power. Here's u. U is the inside function. So we're going to let u be what's inside our parentheses. It's the input function. Then y becomes u to the 7th power. dy dx dy du du dx. Here's my chain rule. So in blue and red, we have some work to do. Okay, first things first. dy du is the derivative of u to the 7th power. This becomes 7u to the 6th power. So I put this down here. du dx is d dx 3x minus 8, and this number is 3. Don't forget, u is 3x minus 8. So wherever there's a u, we replace this with 3x minus 8. So dy dx, 7, 3x minus 8 to the 6th power times that 3. Now I'm going to switch the order in which I multiply, and 3 times 7 becomes 21. You get 21, 3x minus 8 to the 6th power. Here's my dy dx. So here's chain rule, ladies and gentlemen. There it is. Number 5. Number 7. Y is the cube root of x minus 7. Which means y is x minus 7 to the 1/3 power. The function inside your parentheses we're going to call u. So u is simply x minus 7. Then y becomes u now to the 1/3 power. Okay. Chain rule now. So if I want, I'll write down chain rule. Dy dx. Dy du. Du dx. I think I'll copy this for the future. Blue derivative, red derivative. All right. So dy du is d du y to the 1/3 power. By power rule, 1/3 u to the 1/3 minus 1, subtracting a fraction and subtracting a whole number. So this is 1/3 u to the minus 2/3. Or we say 1 over 3u to the positive 2/3, which is 1 over 3 cube root of u squared. So this is 1 over 3 cube root of u squared. Du dx is d dx x minus 7, and this derivative is 1. So this is times 1, du dx. Don't forget what u is. Right? U is going to be x minus 7. So x minus 7 I replace down here for this u, x minus 7. So let's see what this is all together. 1 over 3 cube root of the u, which is x minus 7 to the 2nd power here. And there we go. Number 9. Y is sine 4x. So what's inside the parentheses here, this u is 4x. I'm going to let u be 4x. Then y becomes sine of u. Okay, and then by chain rule, we need dy du in blue, du dx in red. So dy du is the derivative of the sine function. That's sine u. Derivative of sine is cosine. So this portion here is cosine. Du dx is simply the derivative with respect to x of 4x, which is 4. So here's 4. dy dx is cosine u times 4. Now don't forget u here is 4x. So here's my u. I'm going to replace that with 4x. Now, we usually write the constant in front of the function. This is function notation, so I'm going to reiterate what I said today. You can't multiply the 4 with the 4x in parentheses. This is function notation. There's an inside function. There's an input here. So you can't say 4 times 4x is 16x. This is 4 cosine of 4x. Function notation. Number 11. Y equals tangent of 1/2 x. This is my u. Right? So we'll let u be the inside function, the input function. Then that means y becomes tangent of u. Chain rule. I'll call that CR for chain rule. So in blue, we need dy du, and in red, we need du dx. So dy du becomes the derivative of tangent. And the derivative of tangent is secant squared. So this portion is secant squared. Du dx. ddx of 1/2 to the x. This derivative is 1/2. So replace that with 1/2. dy dx, secant squared u, let's not forget. You got to replace u with 1/2 to the x power. Times 1/2. So it becomes simply 1/2 secant squared 1/2 x. Okay. And this is number 11. I'm going to pause for a few seconds here. I'm going to check for a few things. Give me 1 minute, and I'll be right back. Okay, I am back. We're going to go to the next one on this list here. That's 11. We'll go to 13. Y equals sine of cosine of x. So now that the inside function is simply cosine, right? This is the u that's inside. So we'll let u be cosine. Then y becomes sine of u. We're going to use chain rule. dy du, du dx. So let's move some of these here. Dy du becomes d du of sine, which is cosine. So I have cosine u. Here, du dx is the derivative of cosine, which is minus sine. So this portion is minus sine. Don't forget that u is cosine. So this u will get replaced with cosine. So in conclusion here now, dy dx is cosine x times that minus sine x, cosine of cosine x times minus sine x. So you will see dy dx become minus cosine of cosine x times sine x. And there you go. $15. Y is secant pi x. U is this inside function. Here's my u. So let u be pi x. Then y becomes secant u. Chain rule now. Blue derivative, red derivative. So that dy du, derivative of u of secant of u. Derivative of secant is secant tangent. So I write down secant u, tangent u for du, dy du. Du dx becomes d dx, the constant pi times x, and that derivative is pi. So this is going to be times the constant pi. don't forget that u is pi x. So in this u and this u, we replace it with pi x. Pi x. dy dx is secant pi x tangent pi x times this constant pi. Now I can't multiply pi with what's in my parentheses because this is function notation. So we typically put pi in the beginning over here. We put those constants. We start off reading left to right with the constant first, so we can switch that order. And there you go. It's chain rule. (17) y equals cosecant of x squared, where u here is the inside function inside your parentheses. U is x squared. Then y equals cosecant of u. So by chain rule now, we have to differentiate what's in blue times what's in red. So dy du is d du of cosecant. That's minus cosecant of u cotangent of u. So this portion is minus cosecant u cotangent u. Du dx is d dx of x squared, and that's 2x. So this portion down here, the chain portion, is 2x. So don't forget, our u is x squared. So we replace x squared wherever there's a u. Final answer, y prime minus cosecant x squared cotangent x squared, and then by the chain portion, there's the 2x. But like constants, we very often put the 2x first, and there's a negative sign, so it's a minus 2x cosecant x squared cotangent x squared. Here you go. There it is. And that's number 17. 19. Y is tangent square root of x. So my u here, we'll say, is the square root of x, which is x to the 1/2. Then y becomes tangent of x to the 1/2. dy du, du dx. Excuse me, that would be a u. Okay. So dy du becomes d du of tangent. Derivative of tangent is secant squared. So here we go. Secant squared u. Du dx becomes d dx, x to the 1/2, 1/2, x to the 1/2 minus 1, which we've seen over and over again as 1 over 2 square root of x. So this is going to be 1 over 2 square root of x. Don't forget u. This u is the square root of x. Replace my u with the square root of x so that we have y prime equal to secant squared square root of x times 1 over 2 square root of x. Now, this is function notation. You could not cancel. Don't think that this goes away and this goes away. That's not happening. So you can take this whole number times the fraction. You'll have secant squared square root of x over 2 square root of x. Here's your derivative. And there you go. $21. Y equals sine 1 minus x cubed. Where here's the u portion here. This portion is u. So we let u be 1 minus x cubed. Then y is simply sine of u. Chain rule. What's in blue times what's in red. So here we need dy du again. Dy du is the derivative of sine, which is cosine. So we get cosine u. We need du dx. So du dx is the derivative of 1 minus x cubed. And that derivative will be minus 3x squared. So this will be times a minus 3x squared up here. So don't forget what u is. U is 1 minus x to the 3rd power. So this becomes 1 minus x to the 3rd. dy dx is cosine 1 minus x to the 3rd, because that's what u is here, times minus 3x squared. But you can't distribute because this is function notation. Y prime minus 3x squared times cosine of 1 minus x cubed, ladies and gentlemen. Here we go. And you're done. 23. Y is the square root of 1 plus x minus x to the 4th power. And I'm going to write this in terms of as an exponential with a fraction as an exponent, rational exponent. 23. So the inside function here, this is our u. So we let u be 1 plus x minus x to the 4th. then that means y equals u to the 1/2. So we get to use chain rule here. In blue, we need dy du, and then in red, we need du dx. So dy du is the derivative of u to the 1/2, which is 1 over 2 square root of u. 1 over 2 square root of u. Now du dx over here. Du dx is d dx of 1 plus x minus x to the 4th power, which would be 1 minus 4x cubed. So this portion is 1 minus 4x cubed. But don't forget what your u is. 1 plus x minus x to the 4th power. That gets replaced down here. So that y prime becomes 1 over 2 square root 1 plus x minus x to the 4th power times 1 minus 4x cubed. Don't forget your chain portion. Now you get to multiply your fractions. So 1 times 1 minus 4x cubed is 1 minus 4x cubed, 2 square root 1 plus x minus x to the 4th power. So there you go. Here's your derivatives here. If we can draw a rectangle. And the x to the 4th power disappeared. Power 4. There we go, ladies and gentlemen. It's number 23. Y is cube root of 6x minus 5. What this means here is, in parentheses, writing as a rational exponent, rational power, this is the 1/3 power by definition. So you remember this is our u. This is based on what we did for lecture. U is 6x minus 5. Then y is u to the 1/3 power. So here's our chain rule. dy du times du dx. dy du becomes d du power 1/3 u to the 1/3 minus 1. 3/3. So 1/3 u to the minus 2/3, or 1 over 3 u to the 2/3, which is 1 over 3 cube root u squared. There we go. Don't forget du dx. So here, du dx is when we differentiate with respect to x, 6x minus 5. So I'm going to move this over here. This derivative is 6. So replace this with a 6. This is the chain portion. But never forget what u is. U is here 6x minus 5. So we replace our u right over here with 6x minus 5. Y prime. 1 over 3. Cube root of 6x minus 5 squared times 6. The 3 and the 6 cancel. There's a 2. Y prime will be 2 over the cube root of 6x minus 5 squared. There we go. 25. $27. Y equals sine squared x. What this means here is that y equals sine of x to the second power. That's the definition of sine squared x. So now the inside function here is inside the bracket or parentheses, however you want to see that. It's still the same. It's just now u becomes sine x. Then what that means is y is simply u squared now. So notice by chain rule, we'll need dy du, we'll need du dx, dy du, ddu, u squared, which gives you 2u. So here's my 2u. The chain portion in chain rule, du dx, is that derivative really of sine. The derivative of sine is cosine. So this portion is cosine. But we know u here is sine x. So this is my u. Replace u with sine x. Y prime becomes 2 sine x times cosine x, ladies and gentlemen. And there you go. This is 27. $29. Y equals tangent cubed of x. What this means is you have the tangent function raised to the third power here. So my u is tangent. This is u. I'm going to let u equal tangent. Then y is really u to the third power here. So notice when we do chain rule here, everything that I do is completely what we did in lecture. It's completely what we did. So dy du becomes d du of u to the third, which is 3u squared. So this portion is 3u squared. Power rule. Du dx derivative of tangent. And the derivative of tangent is secant squared. So my u now, we want to remember to be tangent. Y prime is 3 tangent x to the second power times secant squared x. And there you go. This is number 29. Y equals the square root of secant, which is y is secant raised to the 1/2 power here. The inside function is secant. So this is my u. So we'll say u is this secant function. Then y becomes u to the 1/2. Chain rule. We need in blue again, dy du. We need in red, du dx. So dy du is d du of u to the 1/2, and then this is 1/2 square root of u. Shows up a lot. Du dx is a derivative of secant. d dx of secant. Derivative of secant is secant tangent. So here's secant tangent. Don't forget u, which is down here, is secant. So by chain rule, I get 1/2 square root of secant times secant tangent. Multiply here your fraction times your whole number. You get secant tangent over 2 square root of secant. Here you go. So this is 31. Y equals the cube root of cosecant, or cosecant to the 1/3 power. U is the inside function inside the parentheses. So let u be cosecant. Then y equals u to the 1/3. dy du, du dx. dy du, u to the 1/3, 1/3 u to the 1/3 minus 1. So get 3/3 here. 1/3 u to the minus 2/3, which is 1/3 u to the 2/3. So we get 1/3 u to the 2/3. Now, du dx is d dx of cosecant. Derivative of cosecant is minus cosecant cotangent. So this portion here is times minus cosecant cotangent. But don't forget what u is. U is cosecant. So here's my u prime, my y prime, sorry. Y prime. 1/3 cosecant to the 2/3 power times minus cosecant cotangent. So you're taking a fraction times a whole number, which will be minus cosecant cotangent over 3 times the cube root of cosecant squared. And here you go. $33. 35. Y equals 1 plus x to the 4th raised to the 2/3 power here. Here's my u. It's inside the parentheses. This is the input function, u. So we let u be 1 plus x to the 4th. Then y is u to the 2/3. Okay, so we're going to need the dy du again. Sorry. And the du dx. dy du. d du. U to the 2/3. 2/3 u to the negative 1/3. So I want to double check. I want to move some of this down, which is 2/3 cube root of u. So this is 2/3 cube root of u. du dx. du dx is d dx 1 plus x to the 4th, which is 4x cubed. So this will be times 4x cubed. Don't forget, u here is 1 plus x to the 4th power. So this u becomes 1 plus x to the 4th power. dy dx is 2/3 cube root of 1 plus x to the 4th power times 4x cubed. So you have a whole number, or a fraction times a whole number. 2 times 4x cubed is 8x cubed over 3 times the cube root of 1 plus x to the 4th power here. There we go. This is number 35. Y is 2 minus x cubed to the 3/2 power. U, the inside function. U here. Let U be 2 minus x to the 3rd power. Then y is u to the 3/2 power. Chain rule. We need dy du, and we need du dx. So, dy du is d du of u to the 3/2, which is 3/2 u, so the 3/2 minus 1. So use 2/2 for 1. You'll get 3/2 u to the 1/2. So this becomes 3/2 u to the 1/2. Du dx. d dx, 2 minus x cubed is minus 3x squared. So this portion becomes minus 3x squared. So dy dx, 3u to the 1/2 over 2 times negative 3x squared. Don't forget to replace u with 2 minus x to the 3rd power. So 2 minus x to the 3rd power is my u. Y prime, negative 9x squared over 2 2 minus x cubed to the 1/2 power, which really means negative 9x squared over 2 square root 2 minus x to the 3rd power here. And there we go. Let's make sure we get this down here. I want to draw a rectangle. So here it is, rectangle. There we go. 37. 39. Y equals 1 plus 6x, and that's raised to the 4th power. So I have a u here. Here's my u. Let u be 1 plus 6 to the x, 1 plus 6x. Then y becomes u to the 4th power. Okay? So we need to get chain rule. dy du, du dx. So let's find dy du. So dy du, d du u to the fourth, it's just 4u cubed. That's 4u cubed. Here's what else we need. Du dx. So this is d dx of 6x, which is 6. So this here is 6. This is the chain portion. So never forget your chain. So y prime is 4u cubed times 6. But our u is 1 plus 6x. So I'm going to replace the u with 1 plus 6x. Final answer. 6 times 4 is 24. 1 plus 6x to the third power. And this is using the chain rule formula. This is 39. 41. Y equals 1 minus cosine to the 6th power. So we have the inside function. This is my u. We let u be 1 minus cosine. Then y becomes u to the 6th power. What this now means, here, chain rule. dy du, du dx. So, dy du. Over here. dy du d du of u to the 6th, 6u to the 5th. We now need du dx. Which is d dx of 1 minus cosine x. Now this is 1 minus cosine x. So this is negative d dx of cosine. Derivative of cosine is minus sine. So don't forget you have a minus, which means simply sine. So this portion is sine. Don't forget u is 1 minus cosine. So this u over here becomes 1 minus cosine. Y prime 6 times 1 minus cosine to the 5th power times your sine function. And there you go. 41. 43. So 43, y equals 1 minus tangent to the 3rd power. My inside function, inside the parentheses, my u, you say let u be 1 minus tangent. Then that means that the function y here is u to the 3rd power. Chain rule. dy du, dy dx. So dy du d du of u to the third, which is 3u squared. And we need now du dx, which is d dx 1 minus tangent. So the derivative here of tangent here, by properties here, this is minus d dx of tangent. The derivative of tangent is secant squared. So this will be minus secant squared. Don't forget what u is. U is 1 minus tangent. Three 1 minus tangent squared times a minus secant squared. Y prime, let's write this down. Negative 3. Let's make sure that 3 is here. Negative 3, 1 minus tangent to the second power, and that's secant squared. So it looks like this pen is acting up. 43. Y equals secant x squared minus 3x plus 8. So your inside function, your u, which is inside the parentheses, is x squared minus 3x plus 8. And then that means y is really secant u. Okay, we need now dy du, that's going to be times du dx. So derivative of secant. And you guys know the derivative of secant is secant tangent. So this portion is secant tangent. Du dx is d dx of x squared minus 3x plus 8. Now, by properties of derivatives, we get 2x minus 3. So this portion here is times 2x minus 3. That's your chain. So don't forget what u is. U here is x squared minus 3x plus 8. Secant of. Again, it looks like we have the following. Secant of u, x squared minus 3x plus 8. Here's the u. So we're going to replace this with x squared minus 3x plus 8 tangent of x squared minus 3x plus 8. And that has to be multiplied to a 2x minus 3. So it looks like we're out of space here. You have to multiply it by the chain. And if you like, we can move some things here. Here, there's a product. And I'll put the 2x minus 3 out in front here. Okay? Times, that's an 8. Apologize. That's an 8. And this is times this class here. Times this here. So there's a product there. So there you go, ladies and gentlemen. Here it is. Okay, that's 45. Now, $47. Might equal sine of the square root of x. Which means y equals sine of x to the 1/2 power here. So within the parentheses again, this is my u. So you let u be x to the 1/2 power. Then y becomes sine of u. Chain rule formula. We need dy du, du dx. So, derivative of the sine function, d du of sine is cosine. So we have cosine here. Now, du dx, the derivative of x to the 1/2 is 1 over 2 square root of x. So like I said, this does show up a lot. Don't forget u is really the square root of x. Y prime cosine square root of x times 1 over 2 square root of x. Now we take the whole number and we multiply it with a fraction. Cosine square root of x over 2 square root of x. Here you go. There it is. It's chain rule. And then 49, ladies and gentlemen. Y equals cotangent of 12x. Again, the inside function, u, inside your parentheses, will let u be 12x. Then that means y equals cotangent of u. So by my chain rule, we need dy du, we need du dx. Dy du is the derivative, and again, it looks like I'm going to have to change this soon, today. Okay, and get rid of one of those. Here. Dy du. Derivative with respect to the u variable of cotangent. Derivative of cotangent is minus cosecant squared u. So this is minus cosecant squared u. Now, du dx is the derivative of 12x, which is 12. So this is times 12. And don't forget u right here is 12x. So I replace this u with the 12x. Y prime minus cosecant squared 12x times 12. But I can't multiply the 12 times 12x. This is functional notation. So y is negative 12 cosecant 12x. And that's 12 times, but negative 12 there. So, ladies and gentlemen, I just went through all of the odd numbered questions in, differentiating these functions. Even though I have all f of x's there, they're all really my y variables. I have this worksheet there for you guys. And I did the odds. This is 1 to 50. Well, I did all the odds there for you guys. So take a look at this, ladies and gentlemen. I hope you enjoyed this video. And check your solutions with what I've done here. Thank you so much.